Hello everyone. In this video, we are going to discuss about energy and power signal. Hope you people know energy and power signal are one among the classification of signals. The basic classifications are of signals are continuous time signal and discrete time signal. If you want to further classify them, we'll get energy and power as one among them. Okay. Now we'll start with the definition of these. First one is energy signal. Signal is said to be energy signal if the total energy E, if the total energy E is finite and non-zero. Signal is said to be energy signal if the total energy E is finite and non-zero, and it is represented as E is less than infinity, which means finite, and greater than 0, which is non-zero. Energy E is finite, which is less than infinity, and non-zero, which means it is always greater than 0. Okay. Now, if you want to give a mathematical representation for an energy signal, total energy of a continuous time signal, let x of t, the total energy of a continuous time signal x of t is given as capital E. Energy signal is represented as capital E, as we marked here. E is equal to integration of minus infinity to plus infinity, integration of minus infinity to plus infinity, determinant of x of t whole square into dt. Okay. Total energy E is given as integration of minus infinity to plus infinity x of t whole square into dt. This is for continuous time signal. If you want to represent energy for a discrete time signal, then we can write it as a total energy of a discrete time signal, that would be x of n, is given as capital E is equal to summation of n is equal to minus infinity to plus infinity x of n whole square. Okay. For continuous time signal, it will be integration of x of t whole square into dt, and for discrete time signal, it is the summation of limit by minus infinity to plus infinity x of n whole square. This is about energy signal. Okay. For energy signal, we are having two equations. One is with respect to continuous time signal and another with respect to discrete time signal. Okay. Next one is power signal. Signal is said to be power. Signal is said to be power signal if the normalized power P is finite and non-zero. Hope people are getting. Signal is said to be power signal if the normalized power P is finite and non-zero. The previous one, energy signal, we marked it as a total energy. You can see we marked it as total energy. I'm highlighting. We marked it as total energy, but now for power signal, remember it is normalized power. If the normalized power is finite and non-zero, okay, it means average power, normalized power, or we can also say it as average power is finite and non-zero, and it is represented as p less than infinity, which means p is finite, and greater than 0, which is for a non-zero. Okay, if you want to represent mathematically the power signal, we can write it as average power average power of a continuous time signal. Average power of a continuous time signal, x of t, is denoted as capital P. We mark the power signal as P. Power signal is always represented by the notation P. So we mark it as capital P is equal to 1 by capital T integration of minus t by 2 to plus t by 2 x square of t into dt. The average power of a continuous time signal or a normalized power of a continuous time signal is represented as capital P is equal to 1 by t integration of minus t by 2 to plus t by 2 x square of t into dt. The same for discrete time signal, we can mark it as average power of a discrete time signal x of n is represented as capital P is equal to 1 upon n summation of n is equal to 0 to capital N minus 1 x square of n. Okay, for a continuous time signal it is 1 upon capital T integration of minus t by 2 to plus t by 2 x square of t into dt, whereas for discrete time signal it is 1 upon n summation of n is equal to 0 to capital N minus 1 x square of n. Hope this is clear. I will repeat the definition. For an energy signal, the signal is said to be energy signal if the total energy is finite and non-zero. The total energy, remember, whereas for power signal, we say it as the normalized power is finite and non-zero, or the average power is finite and non-zero. Remember these four equations with respect to energy signal and power signal, which are very much useful for our next classes, or in the next video we are going to discuss about problems on power signal and energy signal. If you people have any doubts, please do put a message on the comment box. We'll be connected. Thank you.